morning, friends. After the discussion of the surface tension, we are considering the one experiment in case of a thin film. Now, what are the three different definitions of the surface tension? First, on the basis of the intermolecular forces. Second is on the basis of the potential energy, and third is the work done. Right? We know that. And already we derived the equation S is equal to F upon 12 and also S is equal to W upon delta A. Actually the same thing we are going to define the three different definitions of surface tension. So keep in mind these three definitions and also what is its SI unit and dimensional formula already we discussed it. Now write the definition of the surface tension and formula in context of intermolecular forces, second potential energy, and third work done. For that purpose, we consider the top surface of a liquid. Now, first thing, what is the surface? Suppose the liquid is filled in a container. So there is the top surface. Inside this, the molecule or the fluid are present below this surface. Each and every fluid is made up of the numbers of the fluid particles. Here the force of attraction exerted between the molecule of a fluid. This type of the force of attraction is known as the cohesive force. That means the force of attraction between the molecule of the particle of the same material, that is known as the cohesive forces. Cohesive forces. What is the cohesive forces? The force of attraction between the two molecules of the same material is known as the cohesive forces. And second type of the force is adhesive forces. Adhesive forces. There is also the force of attraction between the two molecules. But here, these two molecules of different molecules. Here the force of attraction between the A molecule and the molecule of a liquid, that is the adhesive force. And that is known as the cohesive force. Cohesive force. Clear this? Okay. Now, these two types of the forces are exerted, cohesive and adhesive. Cohesive force, that means the force of attraction between the two molecules of the same material, and here adhesive force is also the force of attraction between the two molecules, but both molecules of different material. Now, cohesive force is more strong than the adhesive force. Cohesive force is more stronger than the adhesive force. Clear this? Okay. Now, what are the molecules on the surface? Has the tendency to go below the surface. To go below the surface. Not all the molecule has this tendency. Only the molecule within the region or within the length is equal to the range of intermolecular forces, R0. What are the molecule of the fluid lies in this region? Region has the length equal to the range of intermolecular forces, has the tendency to go inside the fluid. Therefore, the layer having the thickness equal to the range of intermolecular forces is known as the surface. Is known as the surface. What are the molecule of the fluid has the tendency to go below the surface? Because this molecule within this surface is under the downward directional force. That means due to the cohesive force is exerted on each and every molecule of this surface, therefore it has the tendency to go below the surface. And due to that reason, this surface is behave as the elastic, and therefore the surface tension is established or produced on the surface between the molecule of the fluid. Clear this? Okay. So on the basis of this, we are going to define the surface tension. Now, as shown in the figure, there is the top of the fluid surface. This we consider the line of unit length. So in this side, as we view from the top, so surface is shown like this way. We consider the line of unit length on the surface. So one side of the molecule apply the force of attraction in this direction, other side apply the force of attraction on other side. So this force of attraction is exerted on unit length of a line and also perpendicular to the line and parallel to the surface. This force is known as the surface tension. For that purpose, as shown in figure, consider a line of unit length. Right? The middle of the surface. The force exerted on both sides of the line, perpendicular to the line and parallel to the surface. Both sides, the force is exerted by the molecule of the fluid. And this force is perpendicular to the line and parallel to the surface. And this force is known as the surface tension. So keep in mind that not the downward directional force is the surface tension. But what are the forces exerted parallel to the surface? As we consider the line of unit length on the middle of the surface, this side of the molecule apply the force of attraction due to the cohesive force, this side also apply the cohesive force. Both forces are perpendicular to the line and also parallel to the surface. So this force is known as the surface tension. Therefore, the definition of surface tension on the base of this force is the force per unit length of the line perpendicular to the line and parallel to the surface is known as surface tension. Again, the force per unit length of a line perpendicular to the line and parallel to the surface is known as surface tension. Clear? Okay. If the length of a line is small l and force is F, then the surface tension is defined as S is equal to F upon L. S is equal to F upon L. SI unit is F has the Newton, length is meter, therefore Newton per meter. Newton per meter. Again repeat the definition on the base of the force or the intermolecular forces. The definition of surface tension is the force per unit length of a line perpendicular to the line and parallel to the surface is known as surface tension. Clear? Okay. Now, if the length of the line is L and force acting is F, therefore the surface tension is defined as S is equal to F upon L. SI unit is Newton per meter. Now the second definition. The potential energy stored per unit area of a free surface of a liquid is known as the surface tension of a liquid. Just we discussed about that. As we apply the force on U-shaped frame made from the wire on wire PQ, so the area of the thin film of a soap is expanded. Therefore, work done against the internal force. This work done stored in the potential energy of a liquid on the surface. Therefore, the potential energy stored per unit area of a free surface is known as the surface tension of a liquid. From this equation or from this definition, equation of the surface tension is equal to S is equal to E upon A is the potential energy divided by the area. E upon A, and SI unit is joule per meter. Joule is nothing but the Newton into meter. Per meter square 1 times meter cancel, therefore Newton per meter is the SI unit of surface tension. Both definition has the same SI unit. And third is also we discussed in earlier experiment, in case of a thin film of a soap solution, the work done to increase the unit surface area of a liquid is known as the surface tension. How much work done to expand the surface by unit area is known as the surface tension. Again, the third definition is that the work done to increase the unit surface area of a liquid is known as the surface tension. Therefore, S is equal to W upon delta E. From this equation, the SI unit of surface tension is joule per meter square, that is Newton per meter. Therefore, all three definitions of the surface tension has the same SI unit, Newton per meter. And dimensional formula is Newton M1 L1 T minus 2 upon L1 L1 cancel, therefore M1 L0 T minus 2 be the dimensional formula of surface tension. Clear this? So there is the three definition. One is the force per unit length of a line, perpendicular to the line and parallel to the surface. Second definition, on the base of the potential energy, the potential energy stored per unit area of a liquid is known as the surface tension. Therefore, S is equal to E upon A. And third is, on the base of the work done to increase the unit surface area of liquid is known as the surface tension. Therefore, S is equal to W upon delta E. Now, sometimes the one bias question is also asked on which factor or on what the value of surface tension is depends. Now, the value of surface tension depends on temperature. Value of surface tension depends on temperature. At critical temperature, the surface tension becomes the zero. At critical temperature, the surface tension becomes zero. For water, the critical temperature is 37.4 degrees centigrade. 37.4 degrees centigrade. Now, the surface tension is decreased with temperature or the increase in temperature. Right? Surface tension is decreases with increase in temperature. With temperature. Again, the surface tension or the value of the surface tension is depends on temperature. At critical temperature, surface tension is zero. Critical temperature of water is 37.4 degrees centigrade. So from this we can say that the surface tension is decreased with temperature. Clear this? Only the three definitions of the surface tension and also SI unit in dimensional formula. Dimensional formula is M1 L0 T minus 2, and from this equation the another SI unit of surface tension is kg per second square. Kg per second square. Clear it? Okay. This figure is only for your understanding how what is the surface. Okay. Now friends, after the discussion of the three definition of the surface tension, how we experimentally measure the surface tension of a given liquid. For that purpose, we are going to discuss about the simple experiment for measurement of surface tension of a liquid. Right? Already we discussed the three definitions of the surface tension. One is on the base of the force, intermolecular forces act on a length of unit line and also perpendicular to the line and parallel to the surface, that is known as the surface tension. Second is on the base of the work done. The work done to increase the unit area of the surface is known as the surface tension. And next is on the base of the energy, surface energy. The surface energy per unit area of the surface is known as the surface tension. Now, how we measure the surface tension experimentally? For that purpose, now we consider the simple balance. One arm of the balance is formed by a glass plate, while at the other arm, here the palm with the weight forms the other arm of a simple balance. We consider the one vessel filled with a liquid whose surface tension is measured, and the container or the vessel filled with a liquid in such a way that the surface of the glass plate is just touches to the liquid filled in a vessel. Right? Okay. Now we add the weight in other part till the glass is just removed from the liquid. So what is the additional weight per unit length of a glass plate? That is known as the surface tension. Here we are going to discuss this thing. What is the arrangement of the experiment? First thing, a fluid will stick to a solid surface if the surface energy between fluid and the solid is smaller than the sum of the surface energy between the solid A and fluid A. What it says there? If the surface energy of a liquid in glass plate is smaller than the surface energy of the A molecule and liquid molecule, sum of the surface energy between solid A and fluid A. Already we discussed about the cohesive and adhesive forces. What is the adhesive force? The force of attraction between the molecule of the same material is the cohesive force. And the adhesive force, that means the force of attraction between the molecule of different material. Here, whatever the surface energy of glass plate and solid liquid surface, this surface energy must be smaller than the surface energy of A molecule and liquid molecule. Sum of the surface energy of the solid A and fluid A. In this case, the fluid is thick with the solid plate. Moreover, there is the cohesive force between the molecule of the glass plate and molecule of a liquid. Now, it's shown in the figure. A flat vertical glass plate below which a vessel of the some liquid is kept. One arm of a simple balance is formed by a glass plate. Right? Below the glass plate, a vessel of the some liquid is kept, which forms the one arm of a simple balance. The plate is balanced. This plate is balanced by the weight on the other side. This glass plate is balanced by the weight placed in palm of the other side, with its horizontal edge just over water. What it says there? one arm of a simple balance, we suspended a glass plate, below which a vessel filled with some liquid, which forms the one arm of a simple balance. This glass plate is balanced by the weight on the other side, with its horizontal edge just over the liquid. So that is the simple arrangement. Now, the vessel is raised slightly till the liquid just touches to the surface of a glass plate. Initially, the vessel is just below the glass plate, not touches the edge. Only the glass plate is balanced by the weight placed in a pan. Now, we just raises the vessel with the liquid in such a way that the liquid just touches to the edge of a glass plate and pulls it down a little because of the surface tension. When the liquid is just touches to the glass plate, at that time what's happened? Glass plate is pulled down due to the surface tension. To balance this force, we had to put the additional weight in pan. Because of the surface tension, therefore, the weights are added till the plate just clear the water. What it says there? First, the glass plate is balanced by the weight placed in the pan. Now, we just raised the vessel with the liquid in such a way that the liquid just touches to the edge of a glass plate. In this situation, the plate is pulled down due to the surface tension. That means the plate is go below due to the surface tension force. Right? Now, additional weight is required in pan to balance the glass plate, and glass plate just clear the water. That means just detached from the water. Suppose the additional weight required is W. The surface tension of the liquid air interface is SLA is equal to as liquid air interface is weight upon 2L. Weight upon 2L. Therefore, MC upon 2L. Equation 1. M is the extra mass required to clear the surface of a glass plate. And L is the length of a glass plate. By substituting the value of M, G and L, we can calculate the surface tension of a given liquid. Only the simple balance at present in our daily life we are using. But here the main thing is that initially the glass plate is suspended or the glass plate is balanced by the some weight in pan. Now we raised the vessel with a liquid in such a way that the surface of the liquid just touches to the glass plate. When the liquid is just touches to the glass plate is pulled down due to the surface tension. Therefore, the additional weight is required to balance the glass plate in such a way that just clear the water or just detach from the water. Suppose the additional weight required is W and the surface tension of liquid air interface is SLA. So SLA is defined as W upon 2L. W is the weight, mg is in downward direction upon 2L. M is the extra mass and L is the length of a plate. Right? By placing the value of M, L and G in this equation, we can calculate the surface tension of a liquid. We can determine the surface tension of a liquid. So there is the easy experiment to measure the surface tension of a given liquid. Clear? Okay.